You ready?
Ready.
1 minute. And begin.
Karen Hatchett Pavlin is in training. Once one of America's elite track and field athletes, Karen is now preparing for the biggest event of her life. The birth of her first child. Although there's no medical evidence that being in shape leads to a smooth delivery, Karen is convinced she has a big advantage going in.
Try and visualize it.
Being in good condition means being in tune with your body and being able to listen to and respond to whatever your body's telling you. Being in good shape really has given me that kind of advantage, hopefully. We'll see.
Okay, concentrate, focus back in.
For husband and coach Rob Pavlin, training for this event is very different from when he coached Karen at the track.
Okay.
And I was really able to detach myself from her at that moment, that she was just somebody who was running that needed encouragement and sometimes needed to be encouraged softly and sometimes needed somebody to tell it just to go run and stop complaining and just get it done and so we can get out of here. But now it's like, you know, when she says to me, look, I'm really tired, can we, you know, I just melt. I mean, because it's our experience instead of just her experience, and that's a big change.
It's a connection.
Good. Oh, God, feel that. You feel an arm there or something,
As
right?
Karen and Rob prepare for the big event, their baby is nearing the completion of a process that began 9 months ago
Hi, Zuri.
with a single cell.
Okay, come on, let's go back.
A woman is born with all the egg cells that she will ever have. There are about 1 million of these primitive cells called oocytes. By puberty, this amount is reduced to 400,000. Over the course of the fertile years, only 400 eggs will grow to maturity. 400 chances to make a baby. Here, with the addition of a ring of supportive nurse cells, an oocyte has developed into a follicle. Several follicles are created each month, but only one continues to develop into a mature egg. Every oocyte and every sperm carries the unique combination of genes that make up our inherited characteristics. Here, the egg is collecting all of its genes in a little sac. The sac is then broken down and dissolved. The gene pool divides in half, and one part is pushed out of the egg. Out of 46 chromosomes, 23 are left, the mother's share of a child's biological inheritance. The eggs are held in the woman's ovaries, the almond-shaped organs connected to the uterus by the fallopian tubes or oviducts. The man's reproductive cells are found inside the 300 feet of coiled passageways within the testicles. At birth, they are immature, lacking tails. Beginning at puberty, the sperm mature at a rate as high as 1,000 a second. The dark blue rods are the 46 chromosomes, the man's genetic identity. But as this primitive sperm divides, 2 cells are created, each carrying just 23 chromosomes. The sperm now grow tails to help navigate the long trip to the egg. When the 23 chromosomes contained in any one of these sperm combine with the 23 chromosomes of a mature egg, the result will be a new combination of 46, the blueprint for a completely new human being. In the ovary, the monthly process of ovulation is about to begin. First, a single follicle expands like a bubble on the surface of the ovary. The bubble ruptures, and the egg's nurse cells are propelled out, seeming to lay out a protective carpet for the egg. These are the first pictures of ovulation ever photographed. The egg is gently caught by the frilled edges of the fallopian tube and led into the narrow channel leading to the uterus. At first, tiny muscle contractions in the fallopian tube push the egg along its way. But then the cilia take over, millions of microscopically fine hairs that slowly sweep the egg along. So slowly, in fact, that it takes 4 days for the egg to reach the uterus, longer than it can survive on its own. If a baby's to be made, the sperm will have to join the egg here in the fallopian tube during the brief period when fertilization is possible. The sperm arrive on the scene during sexual intercourse at the moment of ejaculation. At male orgasm, typically several 100 million sperm are ejaculated into the woman's vagina. They have a common goal: get to the egg and fertilize it. Only one, if any, will succeed. Millions of sperm die at the first pass, destroyed by the vagina's protective acidic environment. The survivors continue up to the cervix, the entry gate to the uterus and egg beyond. If a woman is not ovulating, the secretion barrier of the cervix spells doom for the sperm. There is zero chance of getting past it. Folds in the mucous membrane trap the sperm, and they struggle to escape for up to 3 days before they die. But during the few days of ovulation each month, with the mature egg waiting, the impenetrable gate of the cervix opens, ever so slightly. Sperm are still trapped by the thousands, but a few find the microscopic channels created in the secretion barrier by the release of estrogen. The surviving sperm are halfway home. They push on through the uterus up to the entrance to the fallopian tube. Of the 300 million that began, perhaps a few thousand remain. Now, within striking distance of their target, they prepare to do what they've come for: fertilize the egg. Just past the fallopian tube entrance, the surviving sperm suddenly stop and rub themselves against the cilia. It is possible that this is the moment when a covering of protein molecules on the sperm surface are stripped off. With the covering removed, the sperm, for the first time, are ready to deliver their chromosomes, fertilizing the egg. So close and yet so far. Of the thousands that make it as far as the fallopian tube, only a few hundred reach the egg. When they get there, they encounter the final and most imposing barrier of all, the egg's protective shell. On the cellular level, this dense cement-like ring is the equivalent of a castle wall 30 feet thick. Special measures are called for. Arriving at the egg, enzymes carried in the sperm's body rush to the surface and form a chemical battering ram. The chromosomes remain in the sperm head, but the tail, powered by energy capsules called mitochondria, changes its motion from regular waves of movement to quick, strong, whip-like lurches. An amazing effort, but without the cooperation of the egg, it probably wouldn't be enough. The support cells that now make up the wall of the egg are changing shape, weakening the wall just enough to draw the sperm in. The sperm keep trying, the explosive energy of their tails driving them along. Most of the remaining sperm die in this last attempt to penetrate the egg. Finally, success. A single sperm has broken through. Instantly, a burst of electrical activity changes the surface of the egg, making it totally impenetrable. 300 million sperm set out. One made it to the finish line. The sperm continues to move for a short time while inside the egg, and then its tail drops off. The sperm's head slowly starts to swell until it is 200 times its original size, preparing to combine its genes with those of the egg. The two large, round structures hold the ingredients for a new human being, half the genes from the woman, half from the man. Now, the moment of fertilization. The two pools of genes appear here as the two interlocking circles. They fuse with immense power. United, they dissolve into the egg, and the blueprint for a new individual is set. A combination of inherited characteristics unique in all the world has been created. Almost immediately, the egg divides itself into two identical cells. These daughter cells are the first of the billions to come that will culminate in the birth of a single new human being, or maybe more. Mother-to-be Karen Hadgett-Pavlin is an identical twin. Like Karen, her sister Kim was also once a track star. Today, Kim is an investment banker, and Karen is an account executive for Xerox. Like many twins, Karen and Kim are close. Much of who we are as people is determined by our genes. Eye color, hair color, looks, even some personality traits. And all of this is set in the first moments of pregnancy, when maternal and paternal genes fuse together. In the first few days of pregnancy, the egg cells continue to divide as they slowly float down the fallopian tube toward the uterus. Sometimes, about once every 300 pregnancies, this group of identical cells may divide in half. Identical twins like Karen and Kim are the result. Fraternal twins develop when two eggs escape the ovary and are fertilized by separate sperm. By day 4, the egg finally reaches the uterus. Now a startling change takes place. The cells begin to differ from one another. Within the egg, a dark-colored blastocyst develops. This ball of cells is preparing to leave the egg behind and move on to the next stage of development. In this process, never before seen on film, the blastocyst shakes the egg like a baby chick about to hatch. After a moment, it succeeds in freeing itself. Once the healthy blastocyst has separated from the egg wall, it floats freely in the uterus. Close up, the blastocyst shows its makeup. The light round cells on the lower right will become the placenta. The dark mass on the upper left, the embryo, which will grow in 9 months into a new baby. Day 5, and the blastocyst finds its way to the uterine wall. Its sticky surface helps it adhere, and the blastocyst implants itself. Sometimes the process doesn't work just right, and the body is quick to respond. Here, 3 round chromosome sacs lie inside a fertilized egg. This occurs rarely, when 2 separate sperm have both managed entry to the egg. Because of the extra half set of chromosomes, this egg could never develop into a normal human being. The body recognizes the problem, and the egg is rejected. These early miscarriages often occur so quickly and automatically that the woman hardly has a chance to register that she has been pregnant at all. Day 21, 3 weeks after fertilization. Clear as glass, the developing heart begins to beat. Blood cells appear, running backwards and forwards in newly constructed blood vessels, their thin walls providing the developing tissues with oxygen. At 4 weeks, the heart beats on, ever stronger. beginnings of a head and face have appeared. This is the start of an eye. The liver takes shape to the left of the heart, the spinal column below. The embryo of almost any animal that has a backbone, from a fish to a tiger to a human being, looks just like this at this early stage of development. But now, in the human embryo, millions of years of evolution are compressed into a few short months. 4 weeks. The embryo is 4 millimeters long. The arms appear as narrow protrusions. This part will grow into a hand. 5 weeks. Primitive fingers have become apparent. The frog-like webbing between the fingers gradually recedes. Week 16. Hands and face are clearly recognizable. The fetus floats in the uterus, surrounded by a protective fluid sac. This flexible coil is the umbilical cord. The umbilical cord belongs to the fetus, but it is connected to the placenta, the vital link between fetus and mother. The placenta, firmly rooted to the uterine wall, is made up of an astonishing network of blood vessels. From the early stages of pregnancy, everything the fetus needs to survive and grow passes from the mother to the fetus through the placenta. In this animated view, the mother's blood, carrying nourishment for the fetus, passes through tiny holes into the placenta's many chambers. What look like trees inside so many boxes are really the branched endings of the fetus's umbilical cord, the villi. The mother's blood must stay separate from the fetus. So how is the fetus nourished? A closer look reveals the secret. The surface of the villi is made of a selectively permeable membrane, a strainer. It allows nutrients from the mother in, but keeps her blood out. The nutrients seep through the membrane into the fetus's blood supply. This system protects the fetus from some harmful substances, but cannot keep alcohol, certain drugs, and some viruses from passing through. This view shows what the process looks like inside the body. Mother's blood shooting into the exchange chamber and bathing the villi, dangling down on either side of the screen. This animation shows the mother's antibodies surging along with the blood into the exchange chamber. For 9 months, the fetus is protected and nourished in this way, and it grows, readying itself for a new life in the world outside the mother. This is an ultrasound picture of the heartbeat just before birth. Now, 18 hours into labor, the baby's condition is carefully monitored, and Karen's endurance is put to the test.
Contraction begins, right? Here it comes. Deep breath. Breathe it out. Good. Another one. Speaking. One more, come on. Stay with it. Good job. Another one, stay with it. Say one more sound.
Hi there, little guy. Hi.
How you doing there? How you doing in there, little baby?